Good morning, good afternoon, good evening. Welcome everyone to another episode of OpenShift TV. Today is a special day for us. I think we're streaming until 2 p.m. contiguously today, but we are starting with our good friends at TriggerMesh. I'm Chris Short, Principal Technical Marketing Manager and Executive Producer of OpenShift TV here at Red Hat. I am joined today by Samir Nyak. I forgot to get the pronunciation of your last name. I am very sorry.
It's Nike.
You can correct me. Naik, sorry.
Nike, yeah.
Um, yes, you can tell it's early and I have not had all of my coffee yet. I forgot to get the last name. I knew I forgot something, as always. But Samir, please introduce yourself now that I know how to say your name. Thank you.
Yeah, hi everyone. My name is Samir Naik. I am an engineer at TriggerMesh here, working remotely from Goa, India.
Awesome.
If you haven't heard of TriggerMesh is a software company that provides a cloud native integration platform for running serverless workloads. Yeah.
Mm-hmm. And you can get to their website and everything at triggermesh.io, which I will drop right now in the chat. If you
Yeah.
haven't heard of them, check them out. The founders are friends of mine from the Cube Native world or Cloud Native world. And there's some Raleigh connections there too. So yeah, TriggerMesh has been on my radar for quite some time. So I'm super happy to have y'all on the channel. I know it's taken some time to get everything lined up. So I'm very glad that we're finally here talking. And it's good to have
Me
y'all
too.
on board.
Yeah, it was a long one in the making.
Yeah. So yeah, what are we talking about today? I love bringing on our partners because they're like, OpenShift is a box, right? Like it is so much within a box, but there's all this stuff outside of Kubernetes,
Yeah.
of your clusters, of OpenShift clusters, of everything. And interacting with some of these like cloud services makes a lot of sense, right? Like sometimes I don't want to run a message bus at scale inside, like I don't necessarily have those skill sets on my team or whatever. Yeah, we make it easier with operators, but when something goes bump in the night, you don't necessarily want to be the one that has to fix that sometimes. So
Yeah.
using some of these cloud-based services with TriggerMesh is possible, and Samir's going to walk us through some of that, and I can't wait.
Yeah. So, like I said, TriggerMesh is a cloud native company, and we most of our work is around Knative, and our cloud platform is a serverless platform. So we have we've built a number of components like sources and sinks for the Knative framework. And a lot of these are available on our cloud, on our SaaS offering that is available at cloud.triggermesh.io. Today, what we've done is we have actually taken off a bunch of these sources which talk to AWS services and release them as an operator on the OpenShift platform. What this means is that you can now uh, use our sources that we've developed for our SaaS platform on your OpenShift clusters and actually use Knative to interact with your AWS services and process workloads on your OpenShift cluster uh, as per your application requirements, right? So that is mostly what we are going to talk about today. It's called AWS TriggerMesh sources for AWS.
Beautiful.
Yeah.
And this is all open source, last I checked, and we're going to walk through all that.
Yes, it is completely open source. We support a quite a quite a few AWS services at the moment.
Mm-hmm.
So I think the community will find it useful to run in their clusters.
Absolutely. Absolutely. All right. Let's get underway now that we've got everybody figured out that it's cloud.triggermesh.io, but it's actually triggermesh.com for the website. Slightly
Yeah.
confusing. Oh well. So many top level domains nowadays.
Yep. Everyone wants the IO, right?
Well, everyone wants the IO until they realize that it's like not like great for the small Indian Ocean country that actually owns the domain. And they're like,
Yeah.
oh yeah, is the .com available? We'll take that now.
Yep. So for today, on this theme, I have like two demos, primarily two demos. We'll just try to squeeze in a third one, where I will try to show you how you can use our Knative sources and put it in a pipeline and get the events from AWS services in your cluster, and then just show how it can how we can show process it on our cluster. They're just two simple demos. So that is what we are going to go through today. So if
Yeah,
you are ready, we can actually
I
start.
like starting simple with things. Let's let it rip.
Yep. So the first demo I have, before I go to the demos, let me just talk about my OpenShift setup. So I have an OpenShift cluster set up on GKE, and I have uh, installed in my cluster the OpenShift serverless operator.
Okay.
So standard procedure to install uh, this operator, and I also have the AWS sources operator, which is provided by TriggerMesh.
Beautiful.
The installation steps, it is a very straightforward installation, but the installation steps can be found at our GitHub repo. It's called the TriggerMesh AWS sources operator. So it goes through the entire installation process. So you shouldn't find it difficult to install. So what this operator does is it installs the controller for our, this is an operator, so it installs a controller for our actual AWS sources, and this is where all the code resides for the controller and the adapters for the various AWS services. All of it
Nice.
is Go, written in Go, and this is actually what we also deploy in our cloud offering for the AWS sources. So this is not some scaled down version of our uh, component. This is actually what we use for the AWS sources.
You
So this,
are dog fooding, as I call it.
yeah, yeah. And I also have the Strimzy Kafka operator, and this is for my second demo where I will be using a pipeline which basically sends messages to Kafka. So, and it is also a Kafka instance is running in our OpenShift cluster as well. So this is if uh, to install the operator, you can just go to the operator hub and search for AWS, and you should find our operator,
Mhm.
AWS sources operator. I've already installed it.
Do you?
So yeah.
Sorry. Do you want to share your screen now
Oh,
or
oh, sorry. I thought
no
I was
worries?
already sharing my screen.
Yeah, yeah. I asked you to turn it off before you forget.
Yeah, just
Realized that
one
might have been
second.
a
I'm
mistake.
sorry
Oh
about it.
well. Sorry.
Yeah, sorry.
Ah, no worries.
So I'll just go recap quickly. So these are the operators that I was talking about: OpenShift serverless operator, AWS sources operator, and Stringzy. Uh, this is the web page of this is the GitHub repo for the operator, and it has got the installation guide. This is the actual controller that is implemented, which the operator deploys. It is again TriggerMesh AWS event sources,
Hmm.
and like I said, just search for AWS sources in the operator hub, and you should have our operator. Yep,
AWS sources. There it is. Installed.
that's it.
Yeah.
Yeah, and yeah. So, so like I said, I have a couple of demos lined up for today. The first one is a demo where I'm going to demonstrate uh, sending and putting a message in a SQS queue, and then using our sources to get that image, get that message in our to our Knative pipeline, and then we will use a simple tool called sockeye to display that event in a web browser. So just if for those not familiar with Sockeye, Sockeye is a web-based cloud events viewer. So any event that is thrown to Sockeye is basically rendered on a web page. So it is a very quick and easy way to see that the events are actually coming to the cluster.
Yeah,
So
and
all of these
I hadn't heard
yeah.
of this project before, but I feel like it could have helped me many times in my past. So I'm very glad it
Yes,
exists
yes.
now.
Yeah, the most popular one is event display, but event display is not so much fun compared to Sockeye. Sockeye is it stays running for a long time, so it's good.
Right. Nice.
So this, like you can see from this diagram, it is a pretty simple setup. We just the yellow boxes are the ones that we are deploying in our cluster. Uh, so so as you can see, the setup is pretty simple. So just before we start, I will go to Amazon SQS and show you that I have created a SQS queue already called my app queue.
Such an original name. I love it.
Yeah. And these are the this is the queue, and this is the resource name for the queue, which is normally which will be specified in our manifest, so that we can communicate with the queue. So let's just get started.
Yeah, let's dive in.
So if we look at the manifests, I'm going to deploy the AWS SQS source, which is indicated by the kind here. Like I mentioned, this is the ARN for the queue. And I need to specify my credentials. So I have already created a secret with my credentials in the cluster called AWS creds. So I'm
awesome.
Referencing those credentials here. Now, like I said, this is a simple demonstration. So what we are doing is for the sync, we are just going to send it to the Sockeye Knative service. So let's just go and apply this manifest.
Ta-da.
Yeah. Oh, I already have the Sockeye service running in the cluster, which I was actually supposed to deploy during the demo, but it's all right.
That's fine. Let's just show people.
So yeah, so this is Sockeye web page. To deploy it is a very simple YAML manifest that deploys the Sockeye service. So let's just take a look at the YAML manifest. So yeah, it's very simple. It just deploys a container, and the name of the Knative service is called Sockeye.
Simple enough.
Yep. So let's do it this way. So this is my Sockeye service. So this is the cloud event viewer. It is web-based, like I said. And as reported here, everything seems to be working fine. So let's just go and post an event, post a message in our SQS queue.
Cool.
And let's say, hello world. So let's say welcome to OpenShift team.
That way you know it's real messages, folks.
Yeah. So it could take a couple of seconds for the messages to show up. So let's just wait a bit. Yeah, this is our first message.
Yeah, there's a lot of complexity between SQS and you, right? Wherever your cluster may be. It's called the internet.
So like you can see here, we already have received. We have already received our 2 messages which says hello world and welcome to OpenShift TV. And this service is actually running in our cluster. So our source is actually doing its job of pulling these events, cloud events from SQS and getting them to our cluster. So what you could do, this is a very simple example where I'm using Sockeye, but you could use your own functions and services to act on these messages and modify them or perform some action instead of just displaying it on screen, right? So this was my very simple first demo. Uh, yeah.
And you did all that without writing a single line of code.
Yes, I did. I did it all by just clicking
you kind of brushed over that, but yes, you didn't write a single line of code. You deployed some operators, you set up an event queue, and off you went, right? Like, that's the goal.
Yeah, that's the goal. So yeah, this is all pre-wired for you, so you hardly need to do anything to get the event to your cluster. But when you are writing your own functions to act on this, yeah, sure, you need to write some code, but
yeah, sure, of course.
Yeah.
But like the simple, like getting things talking to each other, yeah, you got to plug in some secrets into your cluster for the project. Sure, absolutely, yeah. But
yeah,
that's about the hardest it gets, you know.
Yeah, you don't need to do any plumbing work to talk to AWS, right?
Mm-hmm.
So yeah, that's what the sources allow you to do. Just as we are on this theme, I just also demonstrate another service that is CodeCommit, AWS CodeCommit. So what we can also do is have a CodeCommit repo and make commits to the repo, and then get those messages again in our. We already have Sockeye running here. It's already running, so we don't need to do anything.
Just
but
tie right into it, yeah.
Yeah, and the spec is mostly identical to what we have already written for the other one, but just you need to specify the branch and the event types that we want to subscribe to.
Makes sense.
By the way,
I don't want somebody's individial branch that they're merging just to see if it works with CI. Give me real events that I care about.
Yes. Just before I continue, all of this is documented in our README, so you can actually visit the README, and then in our code repo we have this config and then samples.
Nice.
So you have a bunch of samples. So actually, if you see, I actually pulled my sample to write this, and just all I did was update this part. So you really don't need to write any code.
Yeah, that's awesome. And I love the fact you're providing samples for folks so they can like easily wrap their mind around this and dive in.
Yeah. So again, I'll just quickly go over my CodeCommit repo that I have set up. It's called OpenShift demo, and in it, the resource AWS resource name is this one. So let's apply it.
Nice.
Yeah.
Cool.
Things look good. I already have cloned the repo here, so let's just fake it.
I mean, Smear's not playing games today. He's got everything cloned. He's not letting the demo gods come in here and try and muck with his work. Don't worry. We make sacrifices every day before we get started streaming.
You never know.
The joys of Git.
Yep.
I almost got into a very deep discussion about how like maybe Git isn't the right tool. This morning, it was like, I'm not ready for that today. Maybe there's something we could do better than Git that's maybe easier to use and brings in more people.
I think it's called SVN.
I think it's called Mercurial. With an SVN
maybe.
plugin and a Git plugin, you're probably good. But
So our Sakai services already rendered the commit message. This is the commit object that we just made to our CodeCommit repo. So the event is right here. So just like that, just like the SQS case, we have the CodeCommit case where things are just working. Yeah. So these were my two simple demos with AWS sources that we have implemented.
Got a quick question, right? And I think we can both kind of riff on this one, right? It's from Narindev. Narindev is our ever unquenchable thirst for knowledge person, as I like to call him, right? Like he is a sponge. He wants to learn everything he can about cloud native ecosystems and everything he can do with them. So a trigger goes off for every event. What kind of events can trigger some change or action? Like, how can we talk about a sample use case maybe of someone using events in their application stack? I can think of a ton of examples, but let's hear from you because you're our guest, and I like to put guests on the spot, I guess.
Yeah, let's say for example, I have AWS S3 bucket where I drop an image, and I want that image to be resized and put into my Dropbox, for example.
Right.
So what I could do is I could set up a S3 event source, which actually we don't have an S3 event source in our package, which we are working on. But what you could do is have an S3 event source that picks up that event, the event about the file being dropped into the bucket.
Right.
And then we could have a serverless function which then resizes that image and have another serverless, another target where maybe you just upload it back to S3, which is resized, or maybe
a different bucket, or a different service completely, or your website service. Potentially, right? Like anything.
Yeah, or what you could also do is have a PDF document which is uploaded, and then you run some OCR software and actually convert it into plain text and drop it back into the bucket, right?
Yes.
You could do things like that. So
and S3 notifications automatically go to SQS, so I don't think you have to set up a lot there, right? Like, it's that's all inside AWS, I think, and like that simple use case, like, can change some lives, right? Because the prime use case always tells people is that before S3 was like multi-region. Yeah, there was a time when S3 was limited to like AZs and stuff, right? Like you had your S3 bucket in these AZs in this region. I worked for a company that did a lot of mail archival services. So we had our own way of creating this distributed pool of archival system before S3 had it. So when S3 finally rolled it out, globally, we realized like we're just wasting tons of money on S3 storage now. We need to roll that system back. And what actually happened was we needed to go through an entire database for each customer of archived messages and put it in the right region, right? So we would have this database of messages, and it would say, okay, go find these messages in these S3 buckets. Okay, fine. Find them all, put them all in an event, send the events as you find them, and then move it to the right region. And then all the other ones, delete, right? Like find the good copy of it, put it in the right region, verify it with all the other ones, and then delete all the other copies. And that was a 3-step SQS process, right? Like we had to go through and say, hey, here's all the messages. Boom. That was another file that we got created for basically, huge S3 buckets across regions. And so then we had to take that, pump that into another S3 bucket to say, okay, go find every copy of this message globally. Great. Here's an export of those message IDs. Fine. Put them in the right region, which was from the original, collection of data, and then delete the rest, right? Like that's how we used SQS to kind of go through that massive process of deglobalizing our storage pool, which thankfully AWS made it possible for us to do. We didn't have to keep all that storage and waste all that money. It just became a standard feature. But yes, people had that need before AWS had it as a feature. So yeah, like queues you can use in so many different ways, and it really does kind of crack open your skull on how you can do work, right? Like you can actually break up work into batches and think about how these functions work. And then you throw Knative on top of it. And it's like, oh my gosh, I can do anything now, right? Like I can just take 5 seconds to do this one thing and then move on to the next event, right? Like it's so cool. Like what you can do nowadays, with just gluing together some stuff and using some code that's already in existence. So do you want to show off anything else?
Yeah, I have another demo actually, which uses Kinesis, which is also another AWS service. So this is a bigger pipeline, and compared to what we actually deployed like a minute ago. This is a pipeline where we are going to subscribe to a Kinesis data source, and then use our components to actually send the Kinesis events to a Kafka cluster. So we are basically acting like a bridge between Kinesis and Kafka, if that makes sense. So events occurring on a Kinesis data stream, you pull it and throw it on Kafka. So this is basically that is the use case, right?
Yeah.
So
awesome.
This is shown in the picture. Is it visible, or should I?
Blow it up a little bit, maybe. Yeah, there you go. Yeah, much better. Right.
So for this demo, what I am going to do is I have already set up a Kinesis data stream called my app stream. Again, original name. So again, these yellow boxes are the ones that we are going to deploy, and these are the channels that we are going to install in between them. So what we are going to do is create a Kinesis source object in Knative that will receive the cloud events. We will then take those cloud events and put it into a Kinesis channel. So what the channel is going to do is it is going to allow us to do the processing asynchronously. So we don't have to wait for the messages to pass completely.
Right.
The thing about taking a Kinesis event and sending it to Kafka. So my setup for Kafka has the Kafka REST proxy. So the public communication is happening through a Kafka REST proxy.
Okay, cool.
So the thing about working with the Kafka REST proxy is that it expects the message to be formatted in a specific way. So what we've done is we are using a transform object in between. So what it is going to do is it is going to take this Kafka Kinesis messages, and it is going to transform them into the expected format, and then give it to our HTTP string sync component. The HTTP sync component is then going to post this message using the Kafka REST API, and eventually it should end up at the Kafka cluster, at the Kafka topic. So all these components that you see in yellow are TriggerMesh components. The Kinesis source is the one that is part of the AWS event sources.
Okay.
The transform is an experimental sync element that we have developed at TriggerMesh. So what it allows us to do is basically write plain old JavaScript to act on those messages and convert them. So it is a quick way of doing that. But in our cloud offering, we have a number of different ways of doing that in the UI. So it is much nicer to do that. But for this demo, I am using this experimental component.
What does the box represent in this picture?
This box?
Yes.
This box signifies the components that we are deploying in our cluster today. Now.
Okay, so inside our
the manifest that we are going,
or like
no, these are the components we are deploying in our cluster. So the outside ones are the services.
Yeah. Got it.
Yeah, and then HTTP sync is based on another TriggerMesh component called HTTP target, which allows us to make HTTP requests as part of a sync object. So you can do a post at the end, things like that. It's similar to the HTTP source, which is part of the Knative project.
Mm-hmm.
This is the target. This is the sync part.
Cool.
So yeah, this is slightly bigger pipeline. And to deploy it, it takes a bit of time because my cluster, I think, is not like you noticed earlier that it is kind of degraded performance state. So
let's put it like this: Samir's cluster is not what I would run in production, but it's good enough for demos.
Yeah. So while preparing, I found that it takes a little time for the API responses to come. So I just went ahead and deployed all the components. I will go through the components later, but let's just see the pipeline in action, right?
Okay.
We'll see that.
Let's see the magic, and then let's break it down.
Yeah, and then let's break it down. Yeah, correct, exactly. So, like I mentioned, the end result is going to be that the events are going to appear on the Kafka topic. So just let's first watch the Kafka topic. Let's put a consumer on the Kafka topic. So for this, what I'm doing is I'm just going to log into my Kafka pod and start a consumer on the queue on the topic that I have set up on the Kafka cluster. So let's just in this terminal, if as the messages start flowing in, we should start seeing it should get displayed in this terminal. And who is sending data to this stream? So I have created a fake application. It's basically a script that all it does is write out a log, right?
Beautiful.
And,
yeah, I mean that's kind of, you kind of need that sample application to just demonstrate something sometimes. Yeah,
that's software engineering, right?
Yeah.
So yeah, and then the system is set up to actually post the application logs to Kinesis using the AWS Kinesis Edge interface. So this is a standard AWS. So my fake application is running in a EC2 instance. So I'm just going to SSH and launch the fake application.
Why not? And it's just going to spew stuff like nonstop, so you just kill that process.
It's just going to randomly generate some IP addresses.
That works.
And, So it's going to take maybe a few seconds before the messages start appearing in the first terminal. So let's just wait.
Yeah, because the first terminal is, yes, it's your box, but it's connected to an OpenShift cluster in GCP somewhere, and this AWS instance is across the internet in theory, doing whatever.
So this instance is sending the data to Kinesis, then Kinesis, then our Kinesis source is pulling the events from Kinesis, and then nicely packaging it and sending it to the Kafka cluster.
So yeah, while we're waiting, Good question here. In general, eventing and sync is like a event triggered action will happen if the event satisfies a condition defined in a sync. Is that a correct statement, I guess? You want to explain like
Uh,
eventing and then sync, the concept itself in Knative, maybe?
I didn't understand the question actually.
So, like eventing, right? Like we see the data coming in, right? Like those are
Yeah.
events. Um, what is a sync in Knative, and how do you use a sync in Knative? I guess is kind of the question.
Yeah. So the main concepts or the main components in a Knative pipeline is something called a source and a sink. The
Hmm.
source, you can think of something that generates a message.
Data, yeah,
So
anything,
yeah,
some kind of,
it generates a,
yeah,
yeah. So in this case, the source is generating the message by pulling it from the Kinesis pipeline, and the sink is where the message is delivered, right? So the event flows between these components. So you can have a source, and then you can have multiple
sinks,
components
yeah,
in between, sinks in between, and you can let the message flow between these sinks. So
nice,
at each you can think of each box as each sink as a box that does something to the message. If you feel like, for example, in our transform
hmm,
sync, it actually it is going to convert it into a specific format. So
right,
you can have it like a pipeline. It's basically a pipeline.
hmm,
You can have multiple functions running in your cluster and acting as sinks and doing a different transformation to the each of the in each of the boxes as the event flows. So that is basically what happens. Like an event comes, you take the event, you transform it however you want, or you act on that message in whatever way you want, and you can pass it along.
hmm,
And in the end, you can the final sync will be how you want it, right? So you
right,
can think of it as like an audio processing pipeline.
yeah. That's a great way of putting it. Yeah, yeah,
Yeah. So you have like all sorts of effects in between.
yeah.
That is what each sync does, and then you have the final artifact, right? Like Justin Bieber singing or something like that.
Well, I mean, just break down the like. I talk. Mike picks up audio. Mike takes an analog
Yeah.
signal, converts it to some kind of, you know, other signal that then gets boosted by a cloud lifter, that then gets converted into a digital signal to go into
Yeah.
my computer, to then go out to the internet, right? Like that is an entire pipeline of how audio would
Yeah.
go. And there's lots of things that happen in that chain of events that does look a lot like a, any kind of Knative pipeline or any kind of CI/CD pipeline, right? Like
Yeah.
everything in programming, I feel like, is a pipeline to an extent, right? It's only when you like start to do like, oh, I'm going to do three things with this and then put it back into a sync, right? Like where it gets like super weird, right? Like so,
Yeah.
everything can be kind of
Exactly.
linear, like if you look at it in the Knative serverless kind of way, or everything can be kind of spidered if you want to, if you want to get really crazy. It's sky's the limit.
Yeah. So that is actually a cool demo. Would actually be, you take an audio clip, send it to a S3 bucket,
Mm-hmm.
uh,
It does
a
a
Knative
translate or
pipeline
something.
picks it, it translates or it transcribes it, and it posts it as lyrics or something.
Yeah, it posted as a blog post potentially, right? Like you could
Yeah.
totally like throw data at an API and have a blog post come out of that if you want, right? Like you
Yeah.
could totally have automatic translations for docs and things like that happening as part of a pipeline. It's pretty cool.
Exactly. Yeah.
Very cool tech.
So yeah. So let's get back to the
Yes, thank you.
demo.
Sorry.
So as you can see here, there were a bunch of messages that came to our Kafka topic expectedly,
Mm-hmm.
uh, which hopefully indicates that things are working. So let's just decode one of these messages. The messages from the Kinesis data stream are actually base 64 encoded. So let's just decode them, decode one of them. And to verify, let's just look for this. 106.
I love how like base 64 encoding has become like ubiquitous when like 10 years ago that would have been like a huge red flag coming across my network.
Yeah. So yeah, you can. It's this is the exact log that was sent, and
Yep, there it is.
this is the log we have picked it up from the